All right, so today we're starting to look at section 2.2, which is solving absolute value equations. So our big idea today is we're creating equations and inequalities in one variable and then using them to solve problems. So we're on page 77. So our essential question that we're trying to get to today, how can you solve an absolute value equation? So the first way we're going to do that is solving them graphically. So absolute value equations differ from linear equations in that they may have two solutions. This is indicated with what's called a disjunction, a mathematical statement created by connecting two other statements with the word or. To see why there can be two solutions, we can solve absolute value equations using graphs. So we want to solve this given equation. So the way they want us to do that is to plot the original function, the 2 absolute value x minus 5 minus 4 on the grid, and then plot a second function, g of x equals 2, as a horizontal line on the same grid, and find the points where the graphs intersect. So easy one, we can do the horizontal line x equals 2, or sorry, y equals 2 on the graph. So then the little harder part is graphing the other function. You can obviously do this very easily on a graphing calculator. I don't have mine with me, so I will go ahead and show you how to do it mathematically as well. So the main thing we should know is that the vertex is at the point 5, negative 4, which is here, 5, negative 4. So one thing to notice then is our function here, we're multiplying by 2, so that's changing the slope of our normal lines from 1 and negative 1 to now our slope would be 2 and negative 2. So if we're trying to figure out where this absolute value equation intersects with the line, our slope is going to be 2, so we will go up 2 and to the right 1 to get a coordinate here, up 2 to the right 1 coordinate here, up 2 to the right 1 coordinate here. So we have our first intersection. If you notice, you have to be careful about the scale because it is going by 2s. Now if we want to go to the other direction, to the left of our vertex here, we'll go up 2 and to the left 1, up 2 and to the left 1, up 2 and to the left 1. So the coordinates where we are intersecting that horizontal line are at 2, 2 and at 8, 2. So our solutions would be the disjunction x equals 2 or x equals 8. Again, you can easily do this on the graphing calculator. And in class, I can show you if you plot both of those lines, there's a tool that will allow you to figure out where they intersect. So I can show you how to do that in class with your calculator. That's how you do it by hand. So a couple quick reflection questions here. Why might you expect most absolute value equations to have two solutions? Because the absolute value expression is not equal to 0, the expression inside an absolute value can either be positive or negative. So there can be at most two solutions. Looking at this graphically, an absolute value graph can intersect a horizontal line at most 2 times. So then what would it look like? Is it possible for an absolute value equation to have no solutions or one solution? It is possible. We're actually going to see those probably, I think, tomorrow. But if we think about it graphically, our absolute value equation looks like a V or an upside down V. So you could have your absolute value equation there. And then if you have a horizontal line under it where you're trying to see where they intersect, obviously that you won't have one. Another way, if we do it upside down, have a line there, those ones would have no solution. Versus if we have an absolute value here and our horizontal line touches at exactly one spot at that vertex, that's when we would have one solution.